In this video, we are going to be looking at predicting products for chemical reactions. That's our main thing. So if I say that I have sodium hydroxide and that reacts with sulfuric acid, my question is, what is going to be on this side? What will it produce? It turns out that in this section, we're going to look at 5, maybe 6 different types of chemical reactions. And if you can sort of look at your reaction and figure out what type it is, then that'll help you predict what products you get. First off, here's just a little self-check. How confident are you that you could predict what each of those reactions will produce on the scale of 1 to 5? I guess I can't see your answers, but this is what we're doing in this section. And these 5 reactions here are examples of the 5 types of reactions that we're going to look at. So the 5 types that we'll look at, I guess including other, are single replacement, double replacement, combustion, simple decomposition, and simple composition. Some people call that formation. And there's other names for all of these. These aren't all the different chemical reactions that exist. There's thousands of those. But these are some basic ones just to get us started. So let's look at each one of those, and I want to be able to identify them and then predict the products for each. So the first one, single replacement. You can identify a single replacement reaction because you're going to have a compound, something that's made up of more than one atom, and you're going to have an element as a reactants. For example, here I have an element, and here I have a compound. If I have that and it says that these are reacting, then typically this is going to be a single replacement reaction. So one thing is going to replace one other thing. That's what it means by single. But who replaces who? When you're doing any of these kind of reactions, typically something will replace something that's like that. So for example, chlorine, as in its ion state, is a minus, whereas magnesium in its ion state is a positive. So those won't react, or those won't replace each other because they're different things. Whereas hydrogen is a positive ion in its ion state. So magnesium, we would say, well, let's kick this guy out and all hook up with chlorine. In other words, if I have something here that could be a positive ion, it's probably going to react with the negative ion over here. So those two will get together, hydrogen gets punted. So to predict my products, hydrogen is going to go off by itself, okay? Plus, the magnesium is going to go with the chlorine. So I'm just going to write that. Now, this isn't all correct so far, but that's just sort of who goes with who. Let's clean up a couple things. Hydrogen, when it's by itself, is known as a diatomic element. In other words, it always appears with its in twos. So I can't just write a hydrogen there. I always have to write H2. That means it's a diatomic element. And there's a bunch of those, like hydrogen, oxygen, nitrogen, fluorine, chlorine, iodine. There's probably some other ones I'm forgetting. Anyway, those are known as diatomic elements. If they're out by themselves, they always come with a buddy. So there's always 2 of them. If they're hooked up with something else, they don't have to have a 2 there. Like if it's hooked up with chlorine, there's no 2 with hydrogen. It's only when it's by itself. Okay, that's cleaned up. This is probably a gas. Now over here, magnesium chloride, probably going to be, I don't know, a liquid or probably aqueous. It'll probably be in solution. But I don't know if the ratios are right here. Magnesium, if you look off the chart, is a 2+ ion. Chlorine's a 1- ion. So to balance those charges, I really need to have a 2 there. Okay, now I'm comfortable with this chemical equation. I've predicted the products. I've written the products down correctly. Probably the last thing I should do is balance the equation. I won't do that for all of these, but I'll balance this one. Okay, 1 magnesium, 2 chlorines, only 1 chlorine there, so I'll put a 2 there. That gives me 2 chlorines. It also gives me 2 hydrogens. Here's 2 hydrogens too. Done. Here's another example of a single replacement reaction. Liquid bromine. Bromine, it's a diatomic, so I put a 2 there. A liquid, might as well put the L. Reacts with aqueous sodium chloride. Sodium chloride is NaCl, and they say it's aqueous, so I'll put an aqueous there. Okay, here's my reactants, and I need to figure out what they're going to produce. An element and a compound, probably going to be a double or a single replacement reaction. So bromine and chlorine are like, so bromine's going to kick the chlorine out by itself. Chlorine's off by itself. It's diatomic, so I'll put a 2 there. Plus, then the sodium hooks up with the bromine. Sodium hooks up with the bromine. Bromine's a 1 minus, sodium's a 1 plus, so this chemical formula of NaBr is correct. Okay, done. I've predicted my products. I could balance, and I should balance too, but I just want to look at writing the equations. So that's single replacement. Double replacement, same thing, except you got 2 of them. So you can identify it. Typically, you're going to have 2 compounds. Compound plus another compound. And what happens is just everybody changes partners. So sodium's currently with hydroxide. Hydroxide's a 1 minus, sodium's a 1 plus. Over here, hydrogen's a 1 plus, chlorine's a 1 minus. So sodium's currently hanging out with this minus. So on the product side, sodium's going to hook up with the other minus. So it'll be NaCl plus, and then this hydrogen's going to hook up with that hydroxide. So H and OH. See how they just sort of switch partners? Double replacement reaction. Looking at the charges, chlorine's 1 minus, sodium's 1 plus, good. Hydroxide's 1 minus, hydrogen's 1 plus. That formula is good there too. Okay, double replacement. Let's try an example. Aluminum phosphate reacting with magnesium sulfate. Okay, so aluminum is a 3 plus. Phosphate off the chart is a 3 minus. That's why there's just one of each of those. Magnesium's a 2 plus, sulfate's a 2 minus. Again, that's why there's just one of each. But now I have to double replace things. So this aluminum, is it going to go with the magnesium or with the sulfate? Hopefully it said sulfate. So aluminum is going to go with the sulfate. I need to fix that formula yet. And then the magnesium is going to go with the phosphate. Magnesium goes with the phosphate. Now let's fix the formulas. I figured out who's going to be hooked together for the products. Let's figure out the formula. Aluminum is a 3 plus, sulfate's a 2 minus. So to balance this, I'm going to need to have 2 of these, because that'll be a 6 plus. And then I'm going to need 3 of these, because then that'll be a 6 minus. Okay, that's a good formula there. Let's try the next one. Magnesium's a 2 plus, phosphate's a 3 minus. So I need to go to 6. So this, I need 3 of those. That'll give me a 6 plus. And then here, I need to have 2 of those, because that'll give me a 6 minus. Okay, good there too. Okay, double replacement reaction. Next one is a combustion reaction. These ones are typically, well, these are by far the easiest types of reactions, because all you need to figure out is you have a fuel and you're burning something. So if they say burn, typically it's going to be a combustion reaction. So say I wanted to burn methane. So CH4, I burn methane. So all the combustion reactions will look just like this. You put down your fuel like that, and then, and then you react the fuel with oxygen. So plus oxygen, you need oxygen to burn it. Yields, and on this side, it's always the same thing, CO2 plus water. I don't have to do any arranging of any of these things here. If it's a combustion reaction, if I have a fuel reacting it with oxygen, I'm always going to get carbon dioxide and water. I guess you can burn things that aren't hydrocarbons, but for the most part, the ones that reactions we'll be looking at are hydrocarbon combustion, so it'll always react with oxygen, CO2, and water. So pick your fuel. Like if you pick glucose, you're burning glucose in your body, you react with oxygen, produces carbon dioxide and water. So you do octane, C8H18, that's octane, put that in your gas tank, you're burning that, reacts with oxygen to produce, surprisingly enough, carbon dioxide and water. Ethane, here's another one, ethane is C2H6, so the formula for that will be C2H6, reacts with oxygen to yield CO2 plus water every time, okay, for combustion. Of course, you'd need to balance all of these, but that's not our topic for the lesson. But that's, once you have the products put out, that's your next step. Okay, another type of reaction is a simple decomposition. Decomposition would mean breaking things down. So to identify it, typically you have a single compound for the reactant, like here, and then it breaks up into its elements. So if I have water, it's going to break up into hydrogens and oxygens, like I've shown here. Notice hydrogen and oxygen are both diatomic, so I have to put a 2 with each of those. Try another example. Gold 3 bromide decomposes. Okay, let's write the formula for that. Gold, it's 3, so that means it's a 3 plus. Bromide is Br, and it's a 1 minus. To balance this, I need to have a 3 there. Okay, so there's my formula for gold 3 bromide. And it says decomposes. Okay, so I go like this, and it breaks into these two things. So I have a gold. Gold's not diatomic, so I just leave it as is. Plus, bromine is diatomic, and so I would write it as Br2. In this case here, again, notice it's not balanced. Let me just balance it real quick for us. I need to get common denominator, so maybe put a 3 there to give me 6 bromines. I put a 2 here, that gives me 6 bromines. I have 2 gold, I'll put a 2 there. Okay, simple decomposition. The next type of reaction is the other way, to compose something. So simple composition. Typically with those you see elements by themselves that you're combining or reacting to form, and then you put them together. So in this case, hydrogen plus oxygen gives me water. So it's a composition reaction. Another example, hydrogen gas plus chlorine gas react. Okay, so hydrogen gas, H2, plus chlorine, so it'd be Cl2, they're both diatomic, yields, now I put them together. So over here it'll be HCl. Let's just check the formula there. Cl is a 1 minus, hydrogen's a 1 plus, so they're even, so HCl is the correct formula for that. I'd probably, again, you'd want to balance that equation. Okay, the last type of equation or reaction that we'll look at is something called another reaction. And really, I don't know about putting this in because everything other than these would be classified as another reaction. But it's just something that doesn't follow the patterns that we've already seen. And so something like this, I've got sodium bicarbonate reacts or decomposes to form sodium carbonate, water, and carbon dioxide. See how it doesn't follow the exact same pattern as others? So we could call this another reaction. On this one, though, I would never ask you to predict what the products would be because they could be quite a variety, so I wouldn't ask you to predict. All right, let's return to our first slide. I asked you how confident you are that you could predict the products. Hopefully you're feeling a bit more confident. This first one, compound and compound, this would be a double replacement reaction. So the hydrogen would go with the HCO3 and the Na would go with the Cl. This next one, yeah, combustion reaction. So it's going to produce, I'll write that, CO2 plus water on that side. Only one compound here, so it's going to break up into its elements. Decomposition reaction. 2 elements here, they're going to combine to form a compound. Sodium chloride, that would be a composition reaction. And finally, I have an element and a compound. This would be a single replacement reaction. So the bromine would kick the chlorine out, so this would become sodium bromide, plus the chlorine would go off by itself. It's diatomic, so I'll put a 2 there. Let me just write what this top one would work out to be as well. Hydrogen goes with this bicarbonate ion to produce H2CO3, plus the sodium would go with the chlorine or sodium chloride. Okay, so those would be the products for those. You want to practice these and get so they're comfortable and that you can recognize each of those types of chemical reactions.